Hello guys, welcome to our channel once again. So today we are going to chat about implementing slowly changing dimension type 2 using Databricks. So this is a very frequently used use case for data warehouse, enterprise data warehousing, where you have to maintain a history of your source data because source is not maintaining it, and being a data warehousing application, you have to keep track of all the changes which has happened over the time. So this can be done in multiple different ways in many different components. Like you can achieve this in mapping data flow as well, or in a SQL Server, or whichever RDBMS you are using, or you can do it in Databricks also. So today we'll see how you can do it in Databricks in in 4 simple steps. So stay tuned till the end, and we will see how we can do it for a single table, or you can even implement this for multiple different tables in a generic way. So before we go to our demo and the code, let's understand what is slowly changing dimension type 2. Okay, so I will show you. Okay, so first thing is to understand what is SCD type 2 before we can uh, start doing it. Okay, so this is a simple table. Suppose it's an employee table which has ID, name, and address. So other two columns are used for maintaining your SCD. You are going to get only ID, name, and address from your source. Suppose you have 4 records. Okay, all of them have different ID. ID is unique, and expiry date is 12/31/9999. It means this is all active records. Now this is current day snapshot. Tomorrow you may get a new source data from your system. So the bottom one is the new data, new snapshot which we have got. Okay, now if you notice here, you will see that there is a one record which is updated, which is ID2. Now the address has changed. Here you'll see one new record has been added, so that is going to be the new insert. And now you will notice the second table does not have the ID1, so that is actually the deleted record. Now we'll see after the merge SCD type 2 how our table should look like. So this is how my table should look like. The ID1 which has been deleted should get marked as D, and the expiry date should get updated with current day, or whichever day we have implemented or we have applied this change. Now you'll notice number 2, ID number 2, we will still retain the previous data. We are not going to delete it. That is the property of SCD type 2, but we have to mark this as expired, and the new record will be inserted with the new address, and which will have expiry date as 12/31/9999. So here how we identify active record is based on the based on expiry date. And you can also notice a new record has been added, which was a new insert. This is how our SCD type 2 works. So these 3 changes are what we have to implement. Okay, now let's go ahead and do our data preparation for this demo. So as I shown you earlier in my PPT, I have created 2 different CSV files. One is the original data, how my snapshot of today's data will be, and there will be one more test data for updated record. Here also you can notice ID1 is being deleted, 2 is updated, and 5 a new record has been added. Now here we will read those CSV files as part of our data preparation. So here we are using delta table feature of Databricks. So if you are not aware of this, you can watch our video on the delta tables, how you can create it. It's a very new feature from Databricks, and it's very useful too. We have a dedicated videos around that. So let's see here how we are using it. So first thing what you are doing is we are reading our CSV file, and we are loading into data frame. This is how it looks. It's the same thing the way we have seen in Excel sheet. As a next step, we are saving that in a delta table, which is a delta format. Okay, now our third step would be to read updated record, which we have got suppose today, which we have to merge. That is done as part of this command 4. Let me execute this. So we have added that as a temp view, and I'll show you how the data looks like. So this is again the same thing what we have seen in our CSV file. This is how our new data is coming from the source. Now next, as a next step, we have to do the SCD operation. So how we have to do is, first thing we need to identify IU and D. So now our task is to identify whether which of the records are insert, update or deletes. What we are going to do to identify that is a simple operation. If you are aware of the SQL joins, it is very easy to find out using left outer joins or the inner joins. The first operation we are doing is to identify if we have got any new record. So we are comparing what we already have and what we have got new using left outer join and the null checks. Here one thing to notice is that when you are comparing this with the existing data, you always keep this condition. So if you are having expiry date, you can use expiry date, or in some cases some of the tables use is active flag also, which is fine. So either of them has to be used to identify the inserted record. So while you are identifying updated record, we are doing an inner join. It means that data is still available in both the tables and it joins on the key columns, and this is an important part here. So this join or this condition should contain all of your non-key columns. We are trying to identify if any of the non-key column has changed, either anyone. If you have multiple columns, all of them should come here. Any of them have changed, we have to mark this as U. And the same way, and the third one is the reverse left outer join. We need to identify something which was available earlier, but it has not come in the today's data source. So this way we are trying to identify all the key columns with their insert, update and delete. Here you can see the outcome of this. Now as expected, number 1 has been identified as D record, which will be deleted. 2 has been identified as update record, and the 5 one is identified as a new record. So I did this just for the demo purpose so that I can show you clearly how the query should look like and how the output will be. Now we are creating a temp view out of this result set, which will be stored in df underscore change. Now last activity will be to merge this data what we have already identified as IU and D. So let's see how we'll do that. So here this is an important step, but I will come to this later. First we will see how we can merge it. It's going to be a very simple query. I have made it very simple for everyone to understand. So if you look at this query, we are using a merge join here. So when we are merging to our delta table employee, and we are using the table, the temp view which we have created after identifying IU and D, will join based on the key column, and we will check if it is U and D. If we have identified that key as update or delete, we have to expire the previous record which we already have. Okay, and we also have to create one case statement, because if it's a D record, deleted record, we'll have to change the flag of the existing record itself. But if it is a update record, we'll have to maintain that flag whatever is already there. So once we have updated our existing record, we have to insert the new record which has come as I, or even the updated ones, because for the updated ones also we need to insert a new record. So that operation is done in a second way. So once the operation is done, this is how my data set looks like. So you can notice the way we wanted. One has expired, which marked as D with the expiry date. Two, the previous record has been marked with the current date because it is expired now. Now this is the active record with U. And the fifth one has also been inserted. Now I'll come to this step which we had skipped. Now when we are using a temporary view, you need to be careful, because temporary views are lazy execution or lazy evaluation. So in case you are doing your merge operation in 2 steps, as soon as your first steps gets executed, your temp view will also get changed, which we don't want in this case. That's the reason what we are doing is, as soon as we have identified our insert, updates and delete, we are writing it into a permanent physical file. so that it does not change. We are writing to the physical file and again we are reading it from here. What it is doing is it is making sure that even after my changes to my permanent table, this is not going to affect my temporary view. That's the whole purpose, but this is a very important step. Okay, thank you, thanks for watching.